Alright guys, welcome back, and in this video we'll be seeing that what exactly is NPM, why it is needed, why it is there in the first place. So starting off with the roots of NPM. NPM used to be an independent company earlier, but now GitHub has acquired NPM. So essentially Microsoft owns GitHub, so that means Microsoft owns NPM as well. So first things first, you know that you are in good company. NPM is a company backed by Microsoft, and Microsoft isn't going anywhere anytime soon. So you can rely on the confidence, on the trust NPM has to offer you. With that being out, number two thing about NPM is that it has been a standard package manager for Node for, almost for the whole time, right? Since Node launched as a runtime for JavaScript till date. So yeah, NPM has been from the very beginning. Now, what is a package manager exactly? Well, package manager, you see that a lot of times what would happen is when you're creating websites, or if you're creating backends, or if you're creating CLI tools, or whatever you're doing, you're gonna need to do a lot of things which are pretty low level. For example, creating a server, right? Now, you would say that it's not low level, but I'm talking relatively according to the language. So, interacting with sockets and the HTTP client module on Node, I'm considering that as low level in this context, right? Although it is not low level, but still, let's just assume, because that involves a lot of work, right? You have to get the chunks of the HTTP request in order, then wait for the whole HTTP request to arrive, concatenate all the data, then parse the response as, whatever JSON or whatever you're expecting, or maybe on the basis of headers. Then you have to make sense of the request which has been made, then do some logic, and then send the response as well in a similar way. So, it kind of becomes complex really quick when you're working with applications which are doing a lot of things, right? So you absolutely just cannot build everything from scratch. You have to build on other people's work, right? So what people do is they would occasionally, whatever they have done is that they would make that open source, and they would maintain it, right? By maintaining, I just mean, usual bug fixes and version upgrades, or maybe feature addition as well. So people maintain those packages, and they are open source, and NPM acts as a repository to host those packages. Right? Now, GitHub is a place to host the whole code, but NPM kind of acts as a repository to host the package only, right? So you can't really browse the code of a package on NPM, because NPM just uploads, just contains the minified tar gz file, whatever it is, like the minified archive of that particular file, right? And a README for your help. Technically, they could display the code, but it's not its main selling point, right? So NPM just hosts all these modules on their website. They provide a nice CLI, and this is where the power of NPM really lies. So it's not a website. NPM is actually a tool, right? Website is just a front for, just discovering packages, and it's not necessary. For example, right? If you want to use NPM as a developer, you do not need to visit website a lot. So what you have to do, however, is use their CLI tool a lot, right? So this is like one of the commands which NPM has. There are a lot of other commands as well. We'll go through all of them. But yeah, NPM acts as a command line tool to fetch and install and manage, remove, update, upgrade all the packages, right? In your Node application. NPM is specifically a package manager just for Node. It cannot work with other languages like Python or Java or any other, right? And as a matter of fact, even Dino does not support it, which is like another runtime for JavaScript, but still it has chosen not to support it out of the box. So the idea is that NPM acts as a package manager, allows you to download, manage, update, upgrade, remove packages easily, right? And with the weekly downloads, when you see that a package has a weekly downloads of like over 1 million or so, you can you can very safely assume that it should be a very, very much used package, right? A lot of people are using it. That means it would be, most probably it would be maintained by a lot of good people, right? So yeah, that's basically it for the introduction part for NPM. That's in general what it is, how it works, and I have just given you a brief idea of, the whole thing, right? So yeah, that's all for this video. I'm going to see you pretty soon in the next one. Hey everyone, welcome back. My name is Mehul, and in this video we'll be taking a look at what is the difference between Yarn and NPM. Now, when you are browsing popular packages like Express or maybe React Native or any other package which is a node module, you're gonna face an option between two packages almost always. The first one being NPM and the second one being Yarn. So Yarn is another package manager which is 100% just like NPM, except the fact that it is Yarn, which is an alternative, and number two, it is backed by Facebook. So Facebook created Yarn. Microsoft owns NPM, although it did not create it, but yeah, they own it. So the idea is that Yarn was born because a couple of years back or so, Facebook, not really Facebook, well, everybody could experience that NPM was very slow, right? In a lot of operations, and it did not include support for lockfiles out of the box. It did not work fast enough. There were no caching strategies which were very good at that moment. So, the tool was lagging a lot, right? And there was no competition in the space. So, competition, when there is competition, the customer gets the benefit. So there was no competition, and the tool did not have a lot of things, which could be implemented. So what Facebook did is that their employees came up with another package manager out of the box, and it kind of started a race between NPM and Yarn. People, NPM trying to get people to use NPM, Facebook trying to get people to use Yarn. And so what happened because of this is that all along the two teams coordinated. They just talked among each other. People saw what NPM is doing, people saw what Yarn is doing. Both were open source, so that's not a problem. And in 2020 now, what has happened is both of the package managers have reached at a point where they are pretty much very similar, right? So Yarn and NPM, I believe I have used both of them for a lot of projects, and pretty much they are just the same now, right? Just you might observe Yarn is a little bit fast on your dev server, NPM is a little bit fast on your production server, all those little things. But the main idea is because both projects are open source and they have shared all their best strategies and everything, both of them are good. You can pretty much go ahead and choose anything, but because this series is on NPM, I would obviously recommend you to stick to NPM only, because Yarn's CLI syntax is a little bit different than NPM. But yeah, I mean, Yarn is good too if you want. NPM is good as well. They're pretty much the same thing now. But the fact that NPM has been around for a long time, and yeah, I mean, a lot of packages have, they have been built with the idea that NPM would be installed. So a lot of times some sort of CLI functionalities might fail if you do not have NPM. I cannot really remember exactly which tool I used just a couple of days back, but yeah, it failed because I did not had NPM installed on a production server. So yeah, that's the idea of using NPM. That's one point for NPM. So yeah, that's basically it for the differences between NPM and Yarn. Not much. Again, there's one thing about Yarn version 2, which is something for a different video. But yeah, when I'm talking about Yarn, I'm talking about Yarn's classic version, right? This version 1 series, right? Yarn version 2 manages stuff in a very, very different way. It does not use node modules. It uses some other plug and play functionality on how modules should be managed. But anyway, that's not the topic. We'll just stick to node modules because it's most widely supported. It has been for a long time. And yeah, for the most part, it's manageable at least. So yeah, that's basically it for this video. I'm gonna see you pretty soon in the next one. Hey everyone, welcome back. My name is Mehul, and in this video we'll be taking a look at how you can download, install and set up NPM and Node for the most part on your systems. Now, it does not make sense to install NPM because it cannot work without Node. So, you just cannot have a system which has NPM installed but not Node, because NPM internally uses JavaScript, which needs Node, or at least a Node-like runtime environment, to be present on the system. So the best way to get started with NPM is to download Node, right? So you can go ahead on node.js.org. Now hear me out. This is for Windows guys. So if you're on Windows, go ahead on node.js.org, download the the LTS version. If you want, you can download the current one as well. It's mostly bug free, but just don't use it on production, right? Just use the long-term stable version on production. So just go ahead and download either one of those. It's a wizard installation. Just follow along with the next thing, and you should be done. For the Linux guys out there, if you're using Mac OS, right? So what you have to do is simply go to your terminal, that is just open your terminal and write brew install Node. And I'm assuming here that you have brew, which is a package manager for Mac OS, right? So NPM is a package manager for Node, and brew is a package manager for your whole operating system, right? And Node is a package for your OS, right? It makes sense. So just go ahead and install brew. Just Google it. It's a simple Ruby script you have to execute in your terminal, and it would be available. I won't be covering that. I'm assuming that you have that installed. If you face any problem, just let me know below. Brew install Node would get the node and set it up for you. Once you do that, it should automatically just link your node as well, but just in case, you can run this as well. So when you run brew link node, it would actually link the binary to your environment so that you are able to run node just like that. Then if you do node v, you're gonna get something like this, right? All right, to my Linux guys out there, what you have to do is you have to install NPM in the most boring way, the Node package manager and the Node as well. So what you have to do is, first of all, just go ahead and run, oops, I'm already root, so I don't need that, apt-get update, right? So once you do that, it's just going to update the repository so that you fetch the right package. Then what you need to do is just say apt-get install NPM, right? And yep, I told you that you need Node before you install NPM. But if you just directly install NPM using apt-get, it will just go ahead and do that for you automatically. But the thing which you have to remember here is that the NPM and Node, which is there in the Ubuntu repositories, is not updated, right? So it's very old NPM. So if you're following this video, make sure in any case to follow the next video as well, where I would show you how you can manage Node versions using a package known as N. So in this video, we'll just stick along and install NPM and Node on Linux, but just make sure to watch the next one as well, just in case. And yeah, I'm just using apt-get, but if you're on a distribution like CentOS or whatever, just use that package manager. Try to figure out the repo for that. And well, if you're on some sophisticated Linux, then I pretty much believe that you can install Node by yourself anyway. So that kind of defeats the purpose of me showing you how to install Node. So yeah, let's just wait for it for some time, and it should be done soon. Alright, so once you do that, you're gonna see that now you have access to Node and NPM, and I guess they updated their repositories. But anyway, I remember the last time I did it, it was like I was getting Node 7 and NPM 4 or 3 here, I guess. But anyway, now this is a pretty decent Node version. Node 10 is a decent version, 10.19. But anyway, in the next video, make sure to watch the next video. I'll show you how you can manage the versioning of your versioning of your Node system installation itself. So yeah, that's basically it for this video. I'm gonna see you pretty soon in the next one. So what is going on, everybody? My name is Mehul, and welcome back to this video, in which we'll be seeing what is NPM versioning and Node versioning essentially, and why would you ever need that. So the idea with node versioning is to have multiple versions of node on your systems, right? It is pretty much like, you can think of it like Python versioning if you're coming from a Python environment. You see that you have virtual environments in Python, if you're able to relate. So what virtual environment in Python is loosely mapped to what versioning is in Node. So the idea is that you can have multiple installations, multiple different versions of Node on your system, and you can switch between them easily without actually causing a chaos to your system. So you can have pretty much like Node 10, 11, 12, 13, 14 installed on your system simultaneously, and you can just work with any one of them if you like. Now, why would you need that thing in the first place? Well, first things first, for example, if you're working with a legacy code base, which probably runs on Node 6, although you should have updated it by now, but I'm just considering some edge case which has some humongous sort of, I don't know, some code written in Node which uses Node 6 and it's not compatible with the upward versions. You should stay running Node 6 on that system only. Now, if you use to code for that system on your primary device, you want to have Node 6 written here, right? Not Node 10, because, that's what your project works with. So you might want to have Node 6 for some legacy projects, and you might want to work with just, Node 12, 13, 14 for your regular projects, right? Because they come with a lot of new features, a lot of performance optimizations. Why not? So that is one reason. Right. The another reason for this could be like a lot of times what happens is when we install packages using NPM, they are not just JavaScript packages, right? They are they could be system binaries as well, which have to be compiled using node.js, right? So it's node-gyp. I might pronounce it wrong because I've never heard it, how to pronounce it. But anyway, the idea is that you can have actual binaries, that is actual code which is compiled, right, as node packages. So as part of node packages, for example. So the idea is that if you have a node binary which is compiled with node version 6 or 7 or 8, it might break or it might not work at all with node versions 9, 10, 11, 12, for example. So for that project, you need to be using node 8 only. If that binary does not support a node version greater than 10, you can just work on that with a node version greater than 10. So that is number 2. The number 3 reason I can think of is just for fun, right? So there's a experimental release for Node and you want to try it out without breaking a lot of things. One way is to install it as a version on your main system, although you can always go ahead and use Docker containers for that, but we won't be getting into that. But yeah, the idea is that you can go ahead and install the highest node version, play it around a little, then downgrade as you like without, all from the terminal. You don't have to touch anything at all as code. So yeah, those are my 3 reasons why you would want versioning with Node. In the next video, we'll see how you can do versioning with Node and how that works. So that's all for this one. I'll see you in the next video really quick. Hey everyone, welcome back. And in this video, let's just go ahead and see how we can manage multiple versions of Node. So just like I said, you have some sort of packages which Node provides, right? And there's this one little handy package called N, that is just the letter N. What this would allow you to do is that it will allow you to just manage your Node installations without creating any sort of problem on your main system. So how do you install it? Well, just go ahead. If you're on Linux or Mac, this will work just fine. My Windows friends, I'm very sorry, but N is not supported on Windows. So what you have to do is you have to work with another package manager, which is known as NPM, right? And if you just go ahead and just Google NPM and not NPM versus N, you're going to see that this stands for Node Version Manager, right? Windows supports this, right? Linux and Mac OS also support this, but I would highly recommend not to go for NPM if you're on Linux or Mac OS, because N is much more simpler to operate. It's much more easier and intuitive. So what you have to do, back to Linux and Mac OS, just write sudo npm install gn, right? And do not worry if you do not understand this command at all. We'll be breaking down all of that later on. Just go ahead and do that for me for now. And of course, sudo is not found for me because I'm already root. Npm install gn, and what I want to do, and not because I was root, just to clarify here, because I'm running this inside a Docker container, and that does not have a sudo binary. So anyway, that is a Docker container running Linux, Ubuntu, just for the record. I'm slow. Yeah, so it's Ubuntu. And for Mac OS, you can do a similar thing, sudo npm install gn, right? So what it would do is that once you run both of these commands, that is either of these commands on Linux or Mac OS, what it's going to do is it's going to make a command known as n, just n, available on your systems, right? I'm going to show you how that works on Mac, because I would be able to use sudo at the appropriate places then. So what you have to do, first of all, is write sudo n and then latest. So what this would do is that it will grab the latest version of Node, which is available, and it will install it on your system parallelly to the already installed Node version. So let's just go ahead and hit enter. It will ask you for your password. Just go ahead and enter that. And you see that it's installing Node 14.4 for me, right? I think I have 14.3 on my system, but 14.4 was released. So that's the latest one. And once it does, it has just installed it. But if you see right now, it has not, it actually changed my Node version as well. I did not expect it to. And yeah, I can just say that it changes your Node version. It will just update your Node version to the latest one as well. All right, so that's fine. And you're gonna see that your NPM is updated as well. So if you were running an older NPM, you see that it installed Node 14.4 with NPM. So it's not just Node is updated, NPM also gets updated. So how do you go back to your previous version? Well, it's simple. Just write sudo n, hit enter, and you're going to see a list of all of your Node versions which are installed. For me, I have 10.17, 13.5, 14, 14.3, 14.4, right? And you can basically see that you can also use D for delete, Q for quit, and just go ahead, and if you want to switch to Node 13.5, just go ahead to that and hit enter. It'll take some time to copy the files at appropriate places and set the path, but in a couple of seconds or so, it will say you that, yep, it has updated and it has restored the NPM as well as Node. So now if you go ahead and write Node V and NPM V, you're gonna see that you have the correct versions. Super handy, super useful. I cannot tell you how many times I use this in a day because of if I'm working with some sort of legacy code base. So again, go ahead. And if you do not want any versions, you can delete them. For example, you can delete 10.17, or maybe I'll just get rid of 14.0 and 14.3. So there it is. It's deleted, it's gone. You can again install a specific version if you want by going sudo n and the version. For example, 6.0. Right? So it's installing Node 6.0 for me now, and it will install an appropriate NPM as well. So you see 6 came with NPM 3.8, so there's that. So if I go ahead and do that now, you're gonna see I have the Node 6 right now, and you can verify that by seeing that flat is not a function on an array, right? Which is, well, available after Node 10 or 11, I guess. So the idea is that I'm just gonna delete this because I don't need that. I'm gonna keep on 13.5. The idea is that you can manage it exactly the same way on on Linux as well. So just go ahead and latest, it's going to install. Okay, so it says me that it needs curl or wget as well because it's running inside a container. It does not has that. So you probably would have curl or wget. So I'm just going to install curl, and now n would be able to operate properly. So if I do n latest, so we have that, right? It's installing Node 14.4 now, and you can go ahead and do Node V oops, you see that we have some path problem here. So just go ahead and copy this as well. So just go ahead and run this command and you should be able to do that just fine, right? Node v and npm v, that's fine. You can also restart your terminal, or you can just do a source of bash rc as well if you want. So yeah, that's basically it for this video. That's how you manage versions with N, a very simple CLI tool written in JavaScript for Node. Amazing. That's all for this video. I'm gonna see you pretty soon in the next one. So what is going on, everybody? My name is Mehul and welcome to this video in which I want to explore what is a Node module, right? So the thing that happens when you install a Node module that is a little bit different than what actually is a Node module is in itself. So you see that I'm on the NPM page of Lodash, which is a very, very popular utility for Node, and it comes with tons of handy features. So if I go to the GitHub repository of Lodash, what you're gonna see is all the source code for Lodash, right? So this is more or less, mostly a lot of part of this would be actually present when you do an npm installation of this Lodash module, right? So the idea with the modules is that it's going to fetch a lot of code, well, mostly a lot of code from a single package name itself. So when you write npm install Lodash, we'll see what install is. But when you write that particular command, what's it's going to do? It's going to come to npm. It's going to fetch the code which is stored on npm. Well, you see that it is on GitHub as well. But just like I said, your packages are hosted on npm as well. So when you do npm install of Lodash, it's not actually going to GitHub. It's actually installing it from the source with a file which is hosted somewhere on npm's infrastructure only. It pulls it down, it extracts that file, and it places it into a folder known as Node modules, right? So let's just go ahead and create a very basic project saying npm basics, right? And I'm gonna open this folder and I'm gonna say npm install Lodash, right? And we'll cover all these commands, but npm install Lodash would just go ahead and do whatever I said earlier. So let's just go ahead and hit enter, and don't worry about these warnings for now. What we can see is now we have a folder called as node modules inside our directory. You can see right here, we have a node_modules folder. This is going to be the primary place where all of the external packages would be placed by npm, right? So for the most part, you never really need to open or explore this folder at all, right? You can just leave this folder as it is. You'd never need to open it. You never need to add files or remove files manually from this folder for the most part again. And yeah, if you go ahead and take a look here, you're gonna see you get Lodash as a dependency here. So all of the dependencies would be listed as folders here. And right here for the Lodash, you can see it has got all these files. And if you take a close look, you're gonna see that these files are pretty much what you're gonna see on GitHub as well, right? For the most part. So, you know, you can just go ahead and see what GitHub has in these folders at the top. But yeah, this is basically same as all these files you can see right here. But a lot of npm packages, what they do is that they post the original source code on GitHub, that is the non-minified and like nicely commented and beautiful code on GitHub. And for the npm, what they would do is they would compress it, they would optimize it, they would minify it, and then they would ship it. So for the most part, a lot of times you might see that the code inside the actual npm files is not same as the code which is available on GitHub. So just keep that in mind. npm and GitHub are not synchronized, right? It is no responsibility of developer to have the same code on the GitHub repo as well as on the npm as a package. So yeah, that's basically it for this video. I just wanted to give you a brief overview of a single module, Lodash, as introducing you what modules are. And yeah, I hopefully assume that you learned about node modules a little bit, and this was enough nice little push for the beginning. So yeah, that's basically it for this video. I'm gonna see you pretty soon in the next one. Hey everyone, welcome back. And in this video, what we'll be doing is we'll be seeing how NPM actually installs that particular module. So in the last video, I installed NPM install Lodash. I installed Lodash by saying NPM install Lodash like that. But what happened exactly? I mean, we can just go ahead and see at NPM we have this package, and just like I said on GitHub, a lot of times the code does not really match. So what happened when I wrote NPM install Lodash? A lot of things to start with. First things, I'm not going to cover the whole process, just the main thing, that is how NPM installs a package. So there's a command called npm view instead of npm install. And if I write npm view Lodash, what it's going to do, it's going to spit me a tar file URL. That is the starball URL. What this is that when you as a developer, when you create an npm package, what you do is that you tar your source code and you upload it to npm. So when a developer is actually creating a node module, the only thing npm receives from the developer is this tar file, right? That's it. NPM does not care what is in the package. It does not care about the GitHub source code or whether you want to host it on GitHub or not. It just cares about getting this tar file, right? So once you have this tar file, once NPM has this tar file, it stores it inside its registry, right? Which is probably a CDN or something, which basically hosts this package, right? So when you do npm install of Lodash, what it does is that it takes this URL, that is the tarball URL, which it got from npm. It goes to this particular URL and it downloads this Lodash file, right? And if we go ahead and just take a look at this file, what you're gonna see that it is an actual, if I go ahead to, or maybe let's just move it here, right? So now I have this Lodash 14.17.5, and if I say tar, just unzipping this file, you're gonna see I have a package with me and I have all these files, right? All these files. So what essentially happened is that npm said, okay, let me just go ahead and see where Lodash is located. It got this URL, it did a curl or wget or whatever on this URL and saved it as a tar file on your system. Then it extracted this tar file into a folder called as node modules. So you see, this is the same file structure. If we see, you have about 6,544 files in this, and if I go ahead inside that whatever that was, the package which we downloaded, we will see that it also has 6,544 files. So what npm just did is that it extracted it out for you inside node modules, right? Now you could do it yourself for one or two packages, but a tool like npm comes really handy. Well, it does not really just do that. It also verifies the integrity of the package, whether it's tampered or corrupted while it was being downloaded. So you can see that if I do npm view Lodash, what it's going to show me is that once you download the star file, the integrity, the SHA 512 hash of that package is this value, and this is the SHA sum for the package. So npm actually matches the SHA as well after it's downloaded, because you do not want to install a corrupted or possibly tampered package, because that could be some sort of untrusted code. So yeah, that was a basic idea on how npm works a little bit under the hood. I believe that's not really required for the most part, and most of the people don't really know that as well. But this is a good thing to know as a front-end developer. If you're getting into front-end, you should basically just know a little bit of nits and grits of how your tooling works, right? So yeah, now if you get in case an error that the SHA sum is not matching, you know that well, why it is not matching. It might be because your ISP or whatever is tampering with your connection or something. So yeah, that's basically it for this video. I'm gonna see you pretty soon in the next one. Hey everyone, welcome back. My name is Mehul, and in this video, let's just go ahead and take a look at what NPM did when I installed the Lodash package. So let me just go ahead and remove everything from this directory actually, and we have a nice clear slate to begin with. So I'm gonna do that thing again, npm install Lodash, and let's just pay a little bit of attention to warnings this time. So we have a bunch of warnings. You see, we can, for the most part, we can just ignore these one because no description, no repository. These would be fixed by the first two warnings. So you see that the first warning we get is that it says that it cannot find a file known as package.json, right? So the idea is, what happens is that NPM, it actually needs to manage your modules. It cannot just install and forget about it, right? Because a package manager has the responsibility to not only just install, but also remove, also update, also, patch in a lot of cases, all of your modules, right? So for that, it needs to have a record. It needs to have a place to actually store the information about all that stuff. Sure, it can go ahead and scan node modules, always, but that is not the best way, because what happens if I go ahead inside node modules, and if I go ahead and create, just create an empty folder like Express. Does that mean I have Express installed? Well, of course no. So that kind of becomes tedious for NPM to just recursively scan node modules for the packages, and it is actually unfeasible as well, because what you'll see in future is that a lot of packages have their own dependencies as well. So for example, you might install a package named XYZ, which depends on Lodash, right? So you essentially install XYZ, but you also have access to Lodash indirectly. So that Lodash module would also be placed inside the node modules folder itself. But if you want to remove XYZ, you expect to remove Lodash as well, right? Because you did not explicitly install it. At least you expect to remove that instance of Lodash, which was installed because of XYZ package. So that's where NPM comes in. Well, for all of that, it needs a file. It needs somewhere to put that information, because it cannot just remember everything. We have files for that reason. So that's what NPM actually complains us for the first time, that it does not has this package.json file available with us. So this package.json is a special file which contains a lot of information about your project, but for the most part it is used by package managers like NPM and Yarn for just listing that what sort of packages, what sort of dependencies your project has, for the most part, right? So this was a basic introduction to package.json, why it is needed, and why it just complains that you do not have this file. That's all for this video. I'll see you pretty soon in the next one. Alright everyone, welcome back, and in this video let's just go ahead and create a simple package.json file real quick, and you can go ahead and create that manually. Nobody's stopping you to do that, but you do not really need to do that. What you can do is you can write npm init, right? And when you run this command, it's going to ask you a lot of questions and you have to answer them, and the value shown in the bracket is the default value, right? So I'm just gonna keep hitting enter, because no field is actually mandatory. So just go ahead and keep hitting enter if you want, and you see that it asks you that is it okay? Yep. And yes, it's done, right? So if I go ahead and see this file now, package.json, you're gonna see that it's a JSON file, of course, which has a bunch of keys and nothing special, right? One little quick tip is that what you can do to generate this file quickly is you can say that I want all the defaults to be available, which is what we did last time, but by just hitting enter recursively, and I don't want to mess around. So there you go. In one command you have your package.json file available. So that's how you're going to create package.json. And now if I go ahead and say npm install lodash, what you're going to see is that it does not complain about the first warning, but it does give us this notice about created a log file. Now this is something different. I'm going to come to that later on, but yeah, just keep that in mind that this is a notice which npm told us. So now the idea is that if you look into package.json now, you're going to see this little section here called dependencies. So we're going to cover this in depth very soon, what this is. Don't worry about that. But yeah, the idea is that npm was able to edit this file by itself without, requiring you to open text editor or, make any sort of changes based on our installation of Lodash package. So it's pretty cool, right? So yeah, that's basically it for the package.json initialization. That's all for this video. I'll see you pretty soon in the next one. Hey everyone, my name is Mehul and welcome back. And in this video, I want to formally introduce you to how to install packages. Now we have been installing packages in the last couple of videos, but we haven't actually seen how to actually, just as a formal video, how to do that. So you already know that you can install it using npm install lodash, right? And we know that what happens under the hood about the npm view and all that stuff. But yeah, when you do that, what it do is that it fetches that URL, does that thing, you know about that. There's a shortcut actually to npm install. You can just leave the whole install word and just write I and just lodash like that, right? And just go ahead and do that. It'll just work in a similar way. And if you try to install a package again and again, you're gonna see that you start getting this messages that updated one package and audited one package. It's not installing it again and again, right? It knows that it is already installed. It knows that it is present. So it just stops and does not install it. So you can safely, if you're not sure if a package is available or not, you can safely go ahead and install it. So yep, that's how npm install works in a nutshell. You can use the whole word npm install, or you can just write the shortcut, that is npm I, and write the name of the package, that is name of package. If it is available, it will install. If it is some garbage package name, then npm would just complain to you that this package is not available, right? It says you that 404, this package is not found. So yeah, that's basically it, how you're gonna install packages with npm. That's all for this video. I'll see you pretty soon in the next one. Hey everyone, welcome back. My name is Mehul, and in this video I want to show you pretty quickly how you can remove packages with npm. So it's just as simple as writing npm install, and that is npm remove and then the name of your package. Right, so for the most part, yeah, I just got it. So anyway, if I want to remove lodash now, I'm gonna write npm remove lodash, and you can see it shows me that it removed one package in 1 second. And if you take a look at package.json now, you're going to see that it has been removed from package.json file as well. You cannot find the lodash keyword anymore. Now, and you can also use uninstall, right? Remove and uninstall both work. But yeah, if you try to uninstall a package which is not available, npm won't complain. It will just say that, yeah, it's all up to date. You don't need to worry about that a lot. So yeah. That was a quick little tutorial on how you can install and remove local packages. In the next video, we're gonna see what global packages are in npm and what is the difference. So yeah, that's all for this video. Stay tuned. I'm gonna see you really soon in the next one. Hey everyone, welcome back. My name is Mehul, and in this video, I'm gonna show you what global packages are in npm and how do they exactly differ from local packages and where they are anyway. So starting off with local packages, what we have been doing so far, that is npm install lodash, npm remove lodash, all this package.json file and all that stuff. It's basically local to this npm basics folder, right? That is the universe of this whole thing. You see that when I'm using npm install lodash, it's not modifying a single file out of this folder, right? Similarly, if I remove the package, it's not modifying anything out of this folder. So it has no system impact. I can pretty much go ahead and copy this folder right here and, just use it somewhere else. Obviously, assuming that Lodash is completely JavaScript, which it is. So yeah, I won't have any hardware issues. So yeah, that's the idea. When you create a project, when you create a local project, what you do is that you install all the things that is required for that project using NPM. So the idea of all this package manager and module system is that every time your project needs a module, you install that. That module would be placed very close to that project that is in the same folder in which you run npm install. And you can access it using JavaScript, you can access it using Node, all that stuff, right? About global modules, the basic use for global modules, the most common use is for the command line applications. So you must have seen those create React app tutorials and installation where you can actually just write create-react-app, right? And it just works magically. So what's happening is that this create React app is actually a global NPM module. It is no different than Lodash installed right here on a module-wise, speaking on a module-wise level. But the difference, however, was that it was installed using npm install in no specific directory. For example, if I do a create React app only, so it's installed in any directory, does not matter in which directory you are. The only difference being that a -- global flag was passed. And for short, you can get rid of a dash and global and just write G. So when you do that, when you do something like that, what happens is that it installs the package, it installs this npm package as a global module. And if your path is correct, if your environment variables are correct, for the most part, you should be able to directly access that particular package which you just installed. Obviously, if it offers as a command line execution using your terminal itself, right? Most of the packages which actually say you to install them globally have a command line usage, right? Create React app is one, Cypress is another, right? So you have all these packages which can be installed globally, and they have their command line usage directly available to you. So what's different? Well, first thing is that global packages can not only be just used as a command line tool if they allow, but they can actually work right out from any script, any node script on your systems, right? For the most part, you don't want to do that because that is not the convention. Your code should be, you should be able to just port all your code except node modules, and the other guy should be able to run it. For that part, if you have global modules, it creates all sort of problems. So yeah, for the most part, you should not have global modules dependency in your projects. But yeah, they are there for your convenience. So that's how global modules work. And if you're interested, you can just go ahead and write npm root-g, and it will actually show you the node modules folder, which is for all the modules, which is for the global modules. Sorry. So if I go ahead into this folder, what you're going to find is I have these are the modules which are installed on my system as global, right? So of course I have N, which was the package manager, which we did very initially. I have React Native CLI, I have NPM. Well, NPM is itself, a package for itself, because then it makes it easier to upgrade NPM by just saying NPM latest. So you can actually get the latest version of NPM installed using this little command. That is npm install globally npm and @latest. Well, this is a convention. We can get into that later on when we study about semantic versioning. But for now, I'm just gonna just give it to you like that. So yeah, that's basically it. That's how you find npm root g anywhere. npm root g just works out of the box, right? So anywhere you run it, it'll give you the location where your node modules are installed. So that's how you find them. So that's all for this video. I'm gonna get back to you in the next one really quick. Hey everyone, welcome back. My name is Mehul, and in this section we'll be taking a look at a lot of things about NPM, how the dependencies work, types of dependencies, semantic versioning in NPM, and how all of that works. So this is going to be an interesting section. Stick along with me. That's all for this video. I'll see you pretty soon in the next one. Alright guys, welcome back, and in this video I want to start with something known as semantic versioning in NPM. So whenever you install a package from NPM, for example request, what you're gonna see is that okay, let's just pick a better package, for example React, why not? So what you're gonna see is that every package you see is in the form of some number dot some number dot some number. There would be always 3 numbers, right? And there would be always 2 dots for every package. You cannot see a package with number 1.3, right? It does not exist on NPM. Why? Because NPM follows semantic versioning of package. What is semantic versioning? Semantic versioning is a standard to, it has some guidelines to version your package. How it works is that you have to follow this sort of notation, major.minor.patch. So the first number is your major number, that is 16 is the React 16 version. Then .minor is the minor version, that is 13, and the patch is the patched version, that is 1 in this case. Now we can easily see that what semantic guidelines tell us is that major version should be changed when there's an incompatible API change. That is, if you update to that particular version, you have to make some sort of changes in your old code as a developer who's using that package, right? So for example, if I update to React 17, I should expect that my existing code base in React could be broken, right? It's not required that it would be broken. It could be broken if if React has updated that particular thing which I was using. Semantic versioning means that if you're making use of a major upgrade, just make sure you update your package to a major version, to a different major version. Similarly, there's a minor version, which they just say that if you add a backwards compatible functionality, for example, if React added a new feature, what it could do is that it could just go ahead and include that in a minor version, right? So even though if I update it to the minor version, it won't affect me effectively because that is just a feature which is being added and I'm not using it really. It just says that patch version should be used when you're making a bug fix, which is backward compatible as well. So, there's a difference between patch and major. That is, if a bug fix is, or maybe if a new feature is incompatible with the previous versions, you have to make a major version upgrade. Otherwise, minor and patch will work just fine. Now, with that being said, you don't have to really read this whole document. I just opened the site for a little bit fun. That being said, just forget about semantic versioning at all, right? Because NPM follows semantic versioning, but no other developer on the planet does. So effectively, it does not make sense to actually stick to semantic versioning. You should know, however, that a lot of packages do follow. I'm not sure about React. React earlier did not follow semantic versioning, but I'm not sure now if they're following it or not. I think they are because they do not really introduce any breaking changes in the patch version as well. So yeah, definitely they are following. But the idea is that semantic versioning is the most abused thing on NPM. That is, no developer on the planet follows it effectively. That means that it is very much possible that there might be breaking changes in patch version update as well. So it is very much possible that you are installing a package. For example, if that package is 16.13.1, it is very much possible that the developer goes crazy and he updates the package to 16.14.1. However, there is a breaking change in the API. So you might update thinking about semantic versioning guidelines, and you might think that, okay, if it is 16.14, it should not have a breaking version, right? Because NPM follows semantic versioning and all that yada yada stuff. But the truth is that NPM does not enforce it. It cannot check that, it has breaking compatibility or not. So developers, they do not know about semantic versioning. They just think that this is some sort of joke or whatever. So they just go ahead and use any version they like. So yeah, I mean, it's a pain, but that's basically the idea. And that is one of the reasons why there exists a file called package.lock.json, which we'll discuss just after the semantic versioning, because I wanted to just make a build up why that file was needed in the first place. So yeah, that's basically it for this video. And that's how semantic versioning works, and that's how you should never really rely on packages using semantic versioning, because nobody follows it. But anyway, you should know about that. So that's all for this video. I'm gonna see you in the next one really quick. So what is going on, everybody? My name is Mehul and welcome back. And in this video, we'll see why we need this nice little file which is created called package.packagelock.json. So in the last video, we saw how semantic versioning works, right? Version 16.13.1, all that stuff. Now, a lot of people who have been using NPM from version 5, that is, we are using NPM version 6 right now. A lot of people who have been using NPM version 5 and, more than that, don't really know that there was no package.lock.json file before NPM 5. And why? I don't know why, but I think I understand why they did not choose it. Because NPM wanted to follow semantic versioning, right? Now hear me out on this video. When you have a project like this, and if you do not have node modules folder with you, but you do have these two files, let's just forget about package lock. Let's just remove that as a matter of fact, right? You do have this package.json file, right? So if you see that it includes Lodash as a dependency, so NPM knows that Lodash is required for this project. So what happens is that when you run npm install, it's going to read this package.json file, it's going to scan through all the dependencies, and it's going to install all of them. In an ideal world, what should happen is that, for example, if you have an old version of Lodash here, for example 4.0.0 or 4.1.0, and there's this new version of Lodash available that is 4.17.15. In an ideal world, what should happen is that NPM should be really able to update this patched version. You see, not the major version, the patch version. That is, it should be able to change that version from 4.0.0 to 4.17.15. So what I'm saying is, let's see. Let's hope that there's a version out there. Oops, I think I'm doing something wrong. Anyway, let's hope there's a version out there which starts with 4.0.0 of Lodash, right? Now, if I go ahead and write npm install, or let me just go ahead and remove the node modules folder first. Now, if I go ahead and write npm install, what's going to happen is that it's going to scan the package.json file. It's going to read all the dependencies and it's going to install them one by one. But pay close attention what happens to our package.json. So if I go ahead and write package.json now, you're going to see that my Lodash is actually 4.0.0 only. Fine, nothing changed there. Let's go to node modules and let's open Lodash and let's see the package.json file inside Lodash. Whoops, you see that we actually have installed 4.17.15 as the Lodash version. We did not install 4.0.0. Why is that? That is because how NPM was designed to work. When you do an npm install, what happens, it goes to package.json, it asks for all the packages inside the dependencies, and it says, well, you are 4.0.0. Okay, let me just go ahead and see the maximum version to which I can update you without actually breaking you, right? So this caret right here has a special meaning. We'll get to that later. But what npm does is that it asks npm registry, hey, this guy is running a very old version of Lodash. To which version we can update this guy so that, things don't burn, but he's running on some latest shit as well. So npm says, okay, this is 4.17. Go ahead and use this. So what it does is that it keeps it here as 4.0.0 for reasons unknown. I don't know. Maybe npm should update it here as well. But yeah, they just keep it here. And what they do is that they actually install the higher upgraded version of the package. Now, from my previous video, you know that developers are actually insane and they do not follow semantic versioning. In an ideal world, this should create no problems because the major update to the package should only add new features and this should only fix compatible bugs, right? But this is not the case in the real world. So people found that a lot of times when they just simply wrote npm install on a different system than the one in which they were developing, their whole builds crashed, right? The package did not work, there were incompatibilities, all that stuff was happening. Why was that? Because on their main systems, while they actually had the real 4.0.0 installed, because they installed it way back when there was no 4.17 release, now in the future, when they changed systems and they did npm install on package.json, well, this still remained 4.0.0, but because npm, the way npm works, they updated it to 4.17 point whatever the version was. And that caused the builds to break because developers weren't following semantic versioning. So this is the reason, this is like one of the reasons package.json was introduced, packagelock.json. So if you see this file, packagelock.json, you're going to see that usually you'll find that this file is very large, and for the most part, you never really need to open this file at all. But yeah, right now you can see that our dependencies inside packagelock.json, you see we have the correct version, and we do not have that caret symbol as well. We also have the URL stored from where it was installed exactly, and we have the SHA 512 integrity hash in case we want to install it again. So yeah, that's the main idea, that packagelock.json is going to hold each and every dependency, and that would become very much clear if I add a dependency like Express, because Express has a lot of its own dependencies, right? So now if I go ahead and take a look at package.json, you're gonna see that Express is running on 4.17.1, right? But if I go ahead and look under packagelock.json, you're gonna see we have all sorts of dependencies. Now, why is that? What are all these dependencies? You see that if I go ahead inside node modules, you're gonna see we get a lot of different folders as well. Now, why are they present? We only needed Express. So you see that Express, if you take a look inside package.json of Express, you're gonna see it itself needs these many packages, right? So it needs these packages. So it needs all these packages. So they are also installed as a requirement for our project. And you see that what happens is with semantic versioning, because Express is using some packages, we are using Express. If I update Express to a newer version, if npm install updates it to a newer version, it might happen that effect cascades into the linked dependencies and everything could set on fire, right? Because nobody's respecting semantic versioning. So what packagelock.json does is that when you install a package, it will not only just lock that package in space and time, it will also lock all the other packages used by that particular package as well in space and time. So you have the version number locked, you have the actual URL from where it was fetched as locked, and you have the integrity of the file locked as well. So you see all those packages are locked. Express is locked with the requires as well. That is what it requires as an individual package. And all these packages are listed as well. So yeah, that's the reason why packagelock.json was needed. I know it's a long video, but it's important to understand why it is needed. The only reason it is needed is that when you change systems, when you shift the environments, you want a consistent module behavior. You do not want to work with debug 2.3.1 in development and suddenly you are using 2.6.9 in production, right? Because it might very well happen that 2.6.9 is not backwards compatible with 2.3.1. It should have been compatible if debug was following the semantic versioning, but unfortunately, most of the developers do not follow that. That is why NPM has to bring packagelock.json. And that is why it did not have this feature baked in from the very start, because obviously it expected developers to follow semantic versioning, which should not have broken the things in the first place. So yeah, that's basically it for this video. I'm gonna see you pretty soon in the next one. Alright guys, welcome back. My name is Mehul, and there's one more thing you need to know about NPM which I missed in the semantic versioning video, is how the package.json packages are actually installed. So in the last video, we saw how misleading this could be. That is using Lodash like this, and it could install basically a higher version. So that's bad. But there's a reason for that. The reason NPM installs 4.17.3 instead of 4.0.0 is because of this caret symbol. So what happens is that this caret symbol by default means to NPM that, hey, just go ahead and just consider this, whatever the version number is, 4.x.x as 4.x.x, where these two x's, make sure to upgrade them as much as possible, right? So this is what this caret symbol stands for. Keep the major number same, just make sure to upgrade these two as much as you can. If you change this caret symbol to a tilde symbol, that is like this, things get interesting. So let me just go ahead and remove node modules now. And let me just go ahead and remove Express as well, because Express is a dirty package. It brings in a lot of oops. I'm using Vim shortcuts in Nano. Anyway, so it brings a lot of packages with it. That's what I was saying. So if we see now, you're gonna see we have just Lodash, but now with this tilde symbol instead of caret. So if I go ahead and do an npm install now, okay, I think we have some problems with the. Okay, I guess I just missed that opening bracket. Yep, npm install now. What's going to happen is that tilde symbol is going to mean something like this, 4.0.x. So it means that, hey, just keep your major and minor numbers same, but go ahead and update the patch version to as much as you can. So if I go ahead inside node modules now, and if I take a look at Lodash and take a look at its package.json file, you're going to see that we get 4.0.1 instead of 4.0.0, right? That was because of the tilde symbol. If we used caret symbol, we got 4.17 point whatever the version was. So that's the thing with NPM. NPM by default falls back to the updating of the patched version, right? So if I install a new package like Express, you're gonna see what NPM does is that it falls back to actually as a caret symbol. So that is the default behavior in NPM, right? There's another behavior you can set, that is just removing all these symbols altogether. So you can just go ahead and remove the Express dependency for now. I'm just going to remove that. And you can remove the symbol at all. So what this would do is that this would install the exact package, that package number only, right? So it won't install anything more, anything less at all. So now if I go ahead and remove node modules, and if I go ahead and install, you're going to see that we actually get the real Lodash 4.0.0 for the first time, right? So if I go ahead and write package.json, you're going to see now we have the version number as 4.0.0, nothing more, nothing less. So that's how semantic versioning works in NPM. That's how you're going to make use of that. And that's it for this video. I'm going to see you pretty soon in the next one as well. So what is going on, everybody? My name is Mehul and welcome back. And in this video, we'll be seeing what are dependencies in your package.json. So let's just go ahead and open NPM basics real quick. And I'm going to open package.json as well. So you see, we have a little dependencies here as a key, which is an object, which has the key value pair in the form of the name of the package and the version number. So what happens here is that this is one of the sections, one of the possible sections of dependencies in your program. You can also have other sort of dependencies like dev dependencies, peer dependencies, all that stuff. So we'll come to that as we proceed, but let's start with the major dependencies now. That is just the dependencies. So when you install a package, for example, Express, it goes directly inside the dependencies JSON key. So if I write package.json, you're going to see that it lands directly inside this dependencies JSON key. This dependencies JSON key means that whenever you do npm install anywhere, in any environment whatsoever, it's going to install these two packages forever. This might sound ridiculous right now, but trust me, this information would make sense after 2 videos when you watch dev dependencies and peer dependencies. What happens with dependencies is when you run this command npm install on your server, on your development environment, on a potato, wherever where npm is installed and node is installed, this is going to install all the packages listed inside dependencies. That's all you have to remember. Just remember to place the most critical parts of your application, without which your application absolutely cannot work, inside the dependencies. And how you do that? Well, it's very simple. You have to do nothing. Just do npm install and the package name. Every time you do that, it's going to automatically go into the dependencies section. That's all you have to remember for now. So yeah, that was a quick video on dependencies. Let's hop into the next one really quick, seeing what is the dev dependencies thing and why it is needed. So that's all for this one. I'll see you in the next video really quick. Hey everyone, welcome back. My name is Mehul, and in this video we want to see about dev dependencies. So in the last video we saw how the dependency key works in package.json, but what happens is a lot of times you use a lot of tooling, you use a lot of npm packages to speed up your development process, or bundle files like Babel, Webpack, stuff like that. These files are not really required to run your application, right? For example, if you are using Lodash as a library in your main code, Lodash is actually required to run your application, right? Because your JavaScript would crash without Lodash package because it cannot find the underscore or Lodash variable. But tools like Webpack, tools like Babel, any sort of library which you use just in development is not really required in production, right? So you can safely not install it in a production environment because you would never be making use of that anyway. So how do you differentiate that? How do you segregate that? Well, you use something known as dev dependencies for that. And what you do is you say npm install webpack, but if you do this, it's going to place that into the dependencies. So you write a flag here and you say save-dev. So what it's going to do is that it's going to add Webpack to your project. No worries about that. But what it's going to do, instead of adding it inside the dependencies object inside package.json, it's going to add it into a section called dev dependencies. So you see, this is the dependencies object and this is the dev dependencies object. Again, same thing, nothing changed. You have the version number, you have the caret symbol in front, which follows the minor patch update, which we talked about earlier. But yeah, the idea now is that you are inside the dev dependencies thing. So what happens now? Well, what happens now is that you suddenly have control over npm install. Let me just go ahead and remove the whole node modules folder now. And what I'm going to do is I'm going to see package.json. You see we have dependencies and we have dev dependencies with us. I'm going to do one thing. I'm going to say echo node env here. You see that it's blank. This environment variable is blank. So what I'm going to say is I'm going to say node env is production. So that means I'm tricking npm into believing that my computer is actually a server, right? And then what I'm going to do is I'm going to do an npm install. Hit enter. What's going to happen now is that if I go ahead into node modules folder, you see that we do not have any webpack folder, right? So webpack is not installed. Why is that? Well, you see, I'm in the production mode. And when you're in the production mode, only these dependencies are installed. Or just like I said, dependencies would always be installed no matter where you are running, right? So when you're in production, when this node env is set to production, which is always, you should always set that as production on your production servers. When you run npm install, it's not going to install any dependency at all inside dev dependencies. Why? Because these are dev dependencies. These are required just for developing the product, not for using the product, not for instantiating the scripts on the main server. So this is the difference between dev dependencies and dependencies. All the dev stuff, all the stuff which you do not really need on production goes inside dev dependencies. They mostly include build tools and just the what do you say it, the package, the combiners and minifiers, all that stuff. And most of the things are going into dependencies which are used by your application. So yeah, that's basically it for this video. I'm gonna see you pretty soon in the next one. Hey everyone, welcome back. My name is Mehul, and in this video I want to cover about something known as peer dependency. Now, peer dependency is something which is just like, your regular dev dependency and dependencies, with a little bit of difference. First difference is you will never need to use peer dependencies if you're just creating your own app. You would most likely need to use peer dependency if you're creating an NPM package. Now, why is that? Well, that is because how peer dependency work. You see that peer dependency is not really a dependency which is strictly required, but you expect that thing to be available from the host, right? So the idea is that, let's say I go ahead and install npm install React DOM, right? So for those of you who haven't worked with React DOM is a reconciler for React. Sorry, it's not a reconciler, it's a renderer for React for the web. So React DOM is basically a package which holds the instructions on how to take that virtual DOM tree which React creates and map it on the real DOM in the browser. But it's useless if you do not have React installed in your application, right? And it would not be the best idea if if you bring your own, if React DOM brings its own React version with it as a dependency, right? Because then you would have two dependencies. You probably would have multiple Reacts in your application. So in this case, what happens is that React DOM, if you go ahead and take a look at its package.json, what it's going to do is that it's going to list React as its peer dependency. So it means that, hey, React DOM is saying that whenever you install it, it's saying to NPM that, hey, I do not have React, but I need React to work. So just make sure to check that host, that is the main application, has React installed. And NPM would say, yep, no problem. I'll just go ahead and check that real quick. And it'll just scan the package.json, check if React is available. If not, it's going to show you a warning, right? So let's just go ahead and let me just go ahead and show you the package.json here real quick. So we just have webpack and express and lodash installed. Let's just go ahead and install React DOM real quick and see what happens. We do not have React installed at the moment, so just make sure you understand, just make sure to have that in mind. Right, so you see that we get this warning right here. React DOM 16.13.1 requires a peer of React, this thing, but none is installed. You must install peer dependencies yourself, right? So again, you can see that this is just a nice little warning, not a sort of a crash or any error. So, NPM is not really enforcing you to install React, but it's just putting you out that, hey, React DOM probably wants React. So just make sure you have that if you want it to be working perfectly. And the way it is specified here, you can see 16.13.0. So basically, React DOM would be happy with 16.12.0 as well as 16.14.0, right? So you can see that we have a semantic versioning thing going on here as well. So even though if you have 16.3.0 as the React DOM would be happy, right? NPM would be happy. React DOM might not be. Again, that's what I'm saying. Nobody's following semantic versioning here. The patch version and the minor version is not supposed to break the backwards compatibility, but do not trust that on the NPM landscape because that is not happening. So yeah, that's basically it for the peer dependencies. You can see it is advantageous when you do not want to bring in your own package, but expect that from the host. Mostly useful for people who are actually building NPM packages, not for you as a regular person who's just building your own project. But yeah, you should know that as well. When you see peer dependencies, you should know. You would be amazed to see There are so many packages out there which have millions and millions of downloads a week, and they are not aware about this concept. The authors are not aware about this, so they do not have peer dependencies in their package.json. They do not know about semantic versioning. So the situation is bad in the NPM ecosystem because the developers are not educated. So I'm just trying to put one stone at a time for crossing that river. So make sure if you develop packages later on in the future, just do not forget about these little things. Peer dependencies, semantic versioning, these are important things, right? So yeah, that's basically it for this video. I'm gonna see you pretty soon in the next one. Hey everyone, welcome back to another section. In this, we'll be discussing about NPM scripts, what that is, how you can use that yourself, and basically get started with using your own custom NPM scripts as well. Let's get started. Alright, so what are NPM scripts? Well, if we go ahead and go back into our package, we're going to see that if we cat the package.json file, there's a section called scripts. Now this is an object in JSON. So obviously it can hold key value pairs. That's number one. Number two is that you have a certain script name as the key and a bash script as the value, right? So you see, you can write actual terminal script here. And of course, if you're running it on Windows, you can write, your command line script or PowerShell if you're using that as your default shell or anything, right? So yeah. So the second argument, that is the value, is the bash script. It could very well be a Python script, like by writing Python 3 and the name of your script, or maybe a Node script by writing Node and something. But the key is interesting. So if we go back on the docs, you're going to see that NPM actually supports a bunch of these keywords out of the box, right? And they have a little bit of special meaning. So you see, if I have a pre-published script, it says me that it would run that script before the package is packed and published, right? So what does that mean? That means that if I go ahead and edit the package.json file inside the script section, if I go ahead and write something like pre-publish, not whatever I wrote there, and what it is going to do is, for example, if I write echo 100 here, and if I try to publish this package, NPM packages can be published if you're creating an actual package. It won't be necessarily required for your main project, but yeah, if I try to publish a package, then this script would be executed. A better example for this video would be actually a pre-install example. So pre-install example, you can see right here. For pre-install, it runs before the package is installed, right? So for example, if you are doing, NPM install of Express, right? And Express has a pre-installed script, then that particular script would run. For example, let's just take a look at this node Sass repository, which is a repository for bindings for using Sass in your project, right? So node Sass is basically a project which exposes C++ bindings of the libsass library to node.js for you being able to use it, right? So because it is using a native C++ software, it needs to do some work as a package. So it has the script sections, and you can see right here, you have post install, you have install scripts, you have, all these other scripts as well. You have pre-published scripts as well, which would be used by the developers when they are publishing. And this post install script is used by you when you install the package. So it kind of like set up the whole thing for you before you actually install the thing, right? So yeah, that's for the available scripts. You can also see this section, npm pre-test, test, and post-test. These scripts are run when you write npm test. Pre-stop is run by when you write npm stop, npm start, stuff like this. So let's just go ahead and write start here, and I'm gonna say echo this script was called, right? Now, if I go ahead and try to do npm start here and hit enter, you're gonna see that what npm does is that it echoes out this script was called. And why is that? Because if you take a look in the package.json, you can see inside the script section, we have the start script listed. Now remember, npm start calls the script directly because this is how it is configured internally, right? It does not mean that you can have anything here and, you know, just write npm xyz. And if you have an xyz script here, it would be called. There's a different procedure to do that. So yeah, npm start can be used for that. But if you want to have custom scripts, what you have to do is you can just go ahead and, first of all, let me just go ahead and create a custom script. So we can go ahead and say custom script, something like that. And I can say echo, this is, a custom script, right? So obviously this does not exist in npm and it is a custom script. So you cannot go ahead and run it custom script. You cannot run it like this, right? Because you see that npm actually offers you, did you mean this? That is run script, right? So what you can do is you can just go ahead and write npm run before actually writing custom script. And then you can go ahead and write custom script, right? So what run does is that it says that, hey, I'm trying to run a script that might not be available as a, you know, as a script which is, you know, already hard coded into npm, like npm start, stop, test, pre-publish, restart, stuff like that. So for that, you make use of npm run, right? So if you try to run xyz, which is not available, you're going to see that you do not have the script. And if you try to just run npm run start, you're going to see that it kind of works just the way it worked before, without the run keyword, right? Because at the end of the day, it is also a script. So npm follows the same algorithm to take a look at start script in the section. So yeah, that was the basic introduction to npm scripts. You're gonna find you using npm scripts a lot of times. Why? Because you can set up small scripts, like for example npm run server, something like this. And what this could do under the hood is that maybe it could run a command like I don't know, like webpack config webpack server.js and I don't know, node index.js, for example, a command like this. So instead of writing this whole thing again and again, what you can do is copy paste this inside package.json inside the server directive and go ahead, just use that. So that's how you're gonna make use of, that's how to make the best use of npm scripts. So yeah, that's pretty much it for the video. I'm gonna see you in the next one really quick. Hey everyone, welcome back. And in this tutorial, let's just take a look at what npx is. So we have been taking a look at what npm is for so long, but there's another thing known as npx, which was introduced in npm 5.2 and above. And although I don't think that there's any official full form of this npx, but I like to think of this as npm extended, right? Hence the X. So what npx does is that it basically allows you to run npm tools without actually installing them globally. Now, what you're going to see is that a lot of times, for example, there are tools like create react app, right? So this is one of the tools. Now, create react app actually initializes your application, your front-end web development project, using the default configuration, the default webpack Babel configuration, all hidden from you. And it is pretty handy packaged. But this is a package which is not used very often because you won't be creating, you know, new React projects every day from scratch, right? You're going to either be working on a single or maybe 2 or 3 projects at a time. So this is something you do not really need to have always on your computer as a global dependency. So to kind of like improve the developer experience for that, what npm did is it came out with a tool known as npx. npx, basically what it would do is that it would allow you, number one, to run local binaries, right? So we're going to cover that. And number two, to run global binaries from npm without actually installing that. So let's just come to point number one, that is running local binaries. So what happens is that if you take a look inside package.json, what you're going to observe is that we have these 3 dependencies. Let me just go ahead and install something known as cowsays, right? So cowsays is basically, you know, just a package which allow you to, and it's cowsay, not cowsays. This basically just creates a cow on the terminal and a bubble in which it is speaking. So anyway, you'll just take a look now. So what's happening now is that I have cowsay installed, but how do I make use of it directly? You see, if I try to use cowsay directly, my shell gives me the error that it is not found. Well, one way is to go into node modules, go into cowsay, go into, I don't know, let's see, build, and I don't really know what would work. So let's see, do something like this. No, not really. So let's see, cowsay, and let's take a look at the CLI. So let's just go ahead and write CLI.js, and I'm going to say hello. So you see how much work I had to do for that. Let's just go back and try it from our root folder. I'm going to say node, node modules, cowsay, CLI.js, hello, right? So this is inconvenient, right? Because this is CLI.js. For some other file, it might be configured, the package might be configured in some other way. So it's not really developer friendly, it's not very useful. One way to fix this is to actually have a script inside NPM itself, inside the package log. So one advantage of script is that you can actually make use of the installed packages. So if I have say something and I do cowsay hello, what's going to happen is that if I run npm run say something, so you see that we execute cowsay hello and it properly executes it, right? But if I try to write cowsay hello right here, it won't work. Now the reason for that is when you run npm run and a script, what npm would do is run the script with the all your packages inside the path environment path variable, right? So that is why it is able to find the correct cowsay package and execute it. This is one way. Another way is to use npx. npx would allow you to run your local scripts directly. So if you run npx cowsay hello, what's going to happen is npx is going to see, oh, okay, I am in a node project, I have packaged and package lock.json files with me. I'm going to go ahead inside node modules and grab this binary which you're saying. So npx cowsay, anything, how are you doing, right? So anything, and it'll work just out of the box. This is one use of npx, that is using it to run local packages. Another use of npx is to actually run global binaries. Now you see that I'm out of my folder now and I do not have any node modules or any package log.json files, anything at all here. So if I try to do cowsay here, it won't work again, and I do not have any node modules. So you can see that we do not have any npm installation in the folder. But npx cowsay hello would still work. Now you see that it takes a little bit of time because it installs the package first, executes it, and then removes the package. That means npx does not keep the package around for you. So you won't find cowsay again, but if you try to run it again, it's going to download it again, it's going to install it, it's going to run the script using your binary, it's going to execute it and remove it at the end of the day. So npx cowsay how are you, and let's throw that in quotes. And you're going to see again, it just downloads it, installs it, runs it, executes it, just gets rid of it then. So it's pretty convenient for things like create React app, which you use very, very less often, right? So that is like one of the use cases for npx. So yeah, npx is basically just an extensible way of installing packages, of running scripts to be precise, not really installing packages. And yeah, that's basically it for how npx could be used. So it's usually useful as a little utility. It might save you a bunch of seconds and minutes. And yeah, that's basically it for this utility there. So that's all for this video. I'll see you in the next one. Alright, so let's start with actually configuring your npm installation global packages location. By that, what I mean is that right now you can see that if you do npm root g, you're going to see that it is installed right here, right? Now, the thing is that you can actually change this location. Now, why would you want to do that? Well, one of the reasons is if your system is configured in such a way that this directory falls under root access, or maybe, you do not have sudo password and you do not want to use sudo to install modules, which is always a good practice, never to use, use sudo as less as you can, because you don't want to give root privileges to unknown scripts. So to do that, what you can do is, first alternative is to either change the directory permissions, or you can altogether move the global packages installation location itself. So what you can do is that you can also see all of your configurations like npm config lsl. When you do this, this is all of your npm configuration, right? So yeah, for that part. And how you can get the prefix. Basically, this prefix is responsible for where your global packages would be stored. So we gotta change this prefix. We change everything. So you see that this folder is blank right now. I'm gonna make a folder here, and I'm gonna say this is global node modules, right? You see the folder does not really mean anything. I've just named it randomly, but I want to make this directory as the, just the root directory for global node modules. So what I'm gonna do is I'm just gonna do a pwd, which prints the working directory for me, which gives me this whole path, which is always a good idea. And the next thing you can do is just write npm config set prefix and then this thing, right? And you're done. So now if you go ahead and install something like say globally, what's going to happen is that it's going to install that inside this particular directory, right? So you can see that we have the global node modules. Well, obviously we need to go into the lib, and then we can find the node modules folder say, right? So now if you add this node modules path to your environment variable path, your scripts would then be able to actually make use of the global modules directly by requiring them. So yeah, that's how you change the global modules. And I'm just gonna configure it back to my user local, because it is perfect for me, so I don't have any reason to change it. But there you go if you want to change it, right? So that's all for this video. I'm gonna see you in the next one. Alright, so in this video, let's just take a look at how NPM manages caching. So caching is basically a technique of storing some of the modules which you are installing locally on your system, so that NPM does not have to hit the network every time without unnecessary downloading, to prevent unnecessary downloading. For example, if you're downloading a package and its version number is same and everything is same, and NPM sees that it has that package already available in the cache, it's not going to install it from the network. But again, this is just completely depends on NPM and how it operates. You should not really rely on cache a lot. So, well, NPM by default, what it does is that it would create a folder called as .npm inside your home directory itself, right? So this folder would be automatically there. You do not have to create it. And when you just take a look at the contents for this is all cache content, right? So if you delete this whole folder, it's not going to matter a lot. But you see that NPM is actually using this as a caching mechanism for building binaries and just packages, just heavy things which take long computation, or maybe just heavy package sizes as well, to just cache them so as to speed up things. So, well, you can go ahead and remove this cache. It will just save you some disk space. And another reason for removing caching could be clearing caching could be if you have some problems with npm install and you believe that there's a corrupted cache, or anything like your network went off and now npm install does not work. The first step should be clearing the cache. So how you can do that? By doing npm cache clean, right? And you can also add a force flag here, so that you don't get this error message. You see that it says you that it actually can heal from corruption and all those issues. But if you really want to forcefully clean the cache, you can do npm cache clean force. Now, one thought of train of thought, whatever you want to say, that do not try to clean your cache manually without any reasons, right? So make sure you have a reason. Something is broken, something is not working, because NPM is good enough in managing its own cache. So you do not really have to worry about this in most of the cases. So yeah, that's basically it for the caching video part. And I'm going to see you in the next one.